So inverter's function is to convert the DC power into AC power so that we can use it in our home appliances. So there is another function these inverters do, which is track the maximum power and also track the grid parameter variation like voltage and frequency. There are two types of inverters, either the standalone inverter or grid tie inverters. Standalone, we use it for isolated system when the system is not connected to the grid, and grid tie inverter, we use it in case of the utility or grid is connected to the solar PV system. So there are mainly three types of inverter structure topology. These are the central inverter, string inverter, and the micro inverters. The first one is the central inverter, where we have only one inverter and we connect all the module. We have it in the field or we have it in the site. We connect it to that inverter. This has some advantages, that it is the most traditional inverter topology and easy system design and implementation. Also, it has low cost per watt, but the disadvantage is that the high DC wiring cost and power loss due to voltage drop, and also system output can be drastically reduced in case of partial shading and string mismatch. Single failure point for the entire system, and monitoring is at array level. The second type is the string inverter, where we have an inverter connected to each string. For example, if we have 10 strings in our system, then we will have 10 inverters, and these have some advantages, such that they have a smaller size when compared to the central inverter, better maximum power point tracking capability per string, scalability for future expansion by adding parallel string, and monitoring at string level. They have some disadvantage, that the higher per watt cost than the central inverter. The third type is the micro inverter, where each module has its own inverter, and this has an advantage, that it is resilient to the partial shading effect, MPPT at module level, highest system flexibility for future expansion, minimum DC wiring cost, monitoring at module level, and the disadvantage are that high per watt cost and high maintenance cost, difficult access for maintenance since these inverters are installed under the PV modules. So here is a comparison between a grid-tied inverter and off-grid inverter, and we see that some feature are required for grid-tied and some feature are not required in off-grid system or off-grid inverters, like shutdown when the grid is down, we need it for grid-tied, and anti-islanding protection, we need it for grid-tied. Energized load during grid failure, it is available for off-grid. Local electric company buys excess or surplus power, it is actually applicable for grid-tied inverters. Overload protection, we use it for off-grid, and the inverter cost, it is actually high for the grid-tied inverters.